It's finally time. Today, we make the Crusher. The enemy that I've wanted to destroy, or I guess you could say crush, for a long time now. The reason why the Crusher is so hard is because it has not one, not four, not two, but three elements. The top, which is the top of the Crusher, it's stationary and doesn't move. The pillar, which connects the top of the Crusher to the head, and of course the head, which moves down and crushes anything below it. And then we have its sprite, we have its animatable body 2D. I don't know what that is. There's its kill area, which is meant to be a collision shape 2D. And there's the flooring, which detects when it's going to hit the floor, which is really self-explanatory. Anyway, first of all, I think I'm going to approach this like a thing in which we can just drag in and assemble whenever we want in the level. So first of all, we should probably add a collision shape 2D to the Crusher. We'll just make it a rectangle shape. I don't really care. Then we can set its children to be editable in the inspector, and then we can drag it across the whole Crusher each time, because we're going to be assembling it. Or we could probably just do something like this, and then we could do the collision shape across. Actually, we probably need a collision shape for... We probably need one collision shape for the actual Crusher, and one collision shape for the pillar. Collision, pillar, and collision Crusher. Okay, then we set this to have a rectangle as well. And it's all going to be customizable, of course. So we have this rectangle. So this is one. And so this is one. And this is one. Okay, now that we have that sorted. Oh, okay, fine. We'll add a static body 2D. Actually, let's just make the root node a static body 2D. Yeah, I think... Actually, no. No, that would be a terrible idea. Because we want it to be able to move. Anyway, now we just drag those to whatever height we need them to be for the actual Crusher. During the levels, the Crushers will go to different heights. Anyway, we've got this script. Oh yeah. What's this warning sign on it? It has no shape, so it can't collide or interact with other objects. Okay. Yeah. I don't think we need the animatable body 2D. I think we're just gonna make it a rigid body 2D. Then we can just drag the kill area, and that can be its area. And yeah, we should probably give this a shape. Anyway, we drag this kill area as well. So we have 3 collision shape 2Ds. We have a static body 2D. We have 3 sprite 2Ds. We have a raycast 2D, a node 2D, and a partridge in a pear tree. Anyway, now let's go to the script. We have one line and one line only. Extends node 2D, which basically means we're getting node 2D functions. And I don't know where to begin. So let's just go to Google, I guess. Where do we begin? We should probably start with leaving some comments first, you know. Okay. First of all, we need the rigid. Oh yeah, I'm gonna rename the rigid body 2D to head. We'll put the head sprite inside the head to keep it consistent. We need the head to be able to move downwards until it hits the ground, and then it travels back up. I think that's a good place to start. We necessarily shouldn't make it more complicated right now. So let's start with that. Okay. Let's go back to Google. Let's go to how to make a rigid body 2D move. Ever since I made the crate code, I've forgotten. Okay, we'll go to the go.docs. We'll just scroll down here until we find something that will let us use the position. There's a property of sleeping. If true, the body will not move and not calculate forces until woken up by another body, for example, a collision. Oh, that sounds cool. What we do need is... maybe the docs aren't the best place to find this. So we need to use apply force. Okay. Yep, that seems to all be in order. Well, we should start with giving it a speed, because we need to control how fast it moves. I kind of want to give the player time to get out of the crusher, even if they are underneath it, so let's just make it... let's make it 100, the same speed as player. No, the player speed is 150, I think. Anyway. Now we can go... let's go back to Google. Yep, then we have the direction bar. So physics process runs every frame. So we have direction. Then we have input dot get vector. Wait a moment. What am I doing? We're not extending from a rigid body 2D. We don't have rigid body 2D functions. Okay, I know. Let's just get the head. Already our head equals head dot position plus equals vector 2 0 1. So that should make it move downwards. Except we need to set this to just head. And that's a good start. Except that's a bit too slow. So we should probably make this speed. And of course we need to times it by delta to make it run the same on all devices. Actually, if we're removing the vector 2, we need a position.y. Head.position.y. Okay. If I press Control S, it's going to close my recording. So we go to scene. I remember this from J38. We're going to save the scene. I believe I've already put this in the level. So we're just going to go over there. Yeah, I put it in the level. Okay, if I did this right, the crusher head should move down. It does move down. We all saw it move down, right? I'm just going to keep killing myself so we can see it move down. Yep, there we go. Okay, so if we... We just need to put the kill area to cover the whole crusher. Why do I have 211 errors? That's a lot of errors. What is happening? Okay, so for my liquid, there's a bunch of... You know what? Get rid of the liquids for now. We don't need them. Not for now. Now we'll test it. Okay, for some reason, we're getting this error. So we'll just go over here, copy it into Google. I mean. This error occurs because your crusher.gd script is trying to move, read, or change the position of an object that has already been destroyed using q_free or free, when in reality I've never done that. So, I don't know. If is instance valid. Oh, I didn't know you could do that actually. Oh, okay. I learn new stuff every day. If is instance valid. Then we put a return. Target object. Position equals target object dot position. Then else return. That should work, I think. I don't know why it isn't. You know what? Let's just remove all of this. It's unnecessary complication. I'm not sure why this error is occurring. Let's try and replicate it again in the game. I don't think a rigid body 2D is the correct node for this. I think we should actually make this a static body 2D. I think all our problems will be solved with this. So let's see what it does now. Okay, it goes through the floor still. But it does work. It does work. It does work. You can see it happening right there. Alright. So, now we need it, when it hits the ground, we need it to stop. That should be our next priority. This part, until it hits the ground. We need to get that part right. Okay, so the ground is a tile map layer, so we need to detect that, but it has a collision shape 2D, the tile map layer. So, how should I approach this? I have an idea. What if I move the raycast 2D underneath the head? So the raycast 2D would move with it. Then I move the raycast 2D to be directly under the crusher head. And so it would move with the crusher. And then we could detect it from there. Okay, that actually sounds good. Go to function to detect when raycast 2D is colliding. That is colliding function. Oh, okay. That's easy. On ready. Oh yeah, we should put this in the on ready section. On ready. The raycast. No, we'll call it floor ray. Equals floor ray. We'll make this camel case, and then the function was if raycast dot is colliding, and we can put this in physics process. If floor ray dot is colliding, and then we put whatever we need to put in here. Well, we can simply stop. So I put an wait a moment. We can just copy this. We can put this inside the function, inside physics process directly. Then we put an else. Then we put this. And then we put return. That should work, I think. And there's an error. Error 212. Node not found, fluorate. Oh, okay, it's inside the head. Yeah, that was a really avoidable mistake. I don't know why I made that mistake. It works, it works. Okay. One thing I do notice here, though, is that the floor ray needs to be really high up towards the crusher, so it's not floating above the ground. Yep, that seems to be good. The crusher comes down now at a reasonable pace. I think it's good. Okay, that's a good start. We can also go to Zone 1 Level 1 by scrolling across all of here. Then we can go to the crusher. We can get its collision crusher. Then we can get this dragged across all of the crusher. And then that can have a collision shape as well. Yep, it works. It works perfectly. For some reason there's a collision here. Oh, it's probably the other collision shape 2D. Apart from that, it works fine though. I wonder what happens if the player is standing underneath it at the moment. Oh well, that's a problem for later. Anyway, let's go back to the crusher by scrolling all the way across again. And then we can do something else, which is making the crusher go back up to its original position after it hits the ground. So let's make a variable, because of course we need to make a variable. So let's put the starting position equals vector 2. So I need to save that. Actually, we should search up how to get position of something. We should just be able to put dot position. Position returns the coordinates relative to the object's parent node, returns the coordinates relative to the entire game world. I think we need global position here. So we're just going to make this equals head.global position. We should put this in func ready as well. It just seems like a better fit there. I still don't know what function 3 does. Actually, I'm going to look it up after this. I'm tired of not knowing what function 3 does. Whenever I type func and then R, it always comes up with func 3, and I still don't know what it does. So we're going to learn today. Anyway, yep, this warning is fine. Let's find out what func 3 does. What does func 3 do? Immediately deletes an object or node from memory. I should have guessed from Q3, to be honest. I thought its effect would be a lot cooler, but it's a Q3 ripoff. Anyway, now that we have this, we can get the starting position. So then we need to lerp back to the starting position. So we need to replace this return with the lerp back. And we're going to do that now. But first of all, now that I think about it, we should probably put this above function ready. So we can use it in any function. And we should still have it in function ready. Because then whenever the scene reloads, it will still be there. Or something like that. I think that's how Godot works. Anyway, how to lerp between positions, and will it move when it lerps? Yes, the object will move when you lerp. Okay, you must call up every frame. Yep, of course it's going to be in physics process. That's what we were planning. So we're going to get the position of the head, and we're going to lerp it to the target position, which is the starting position. And then we're going to put speed times delta with it. All right. That sounds fine. So we go here. Head.global position. That's an amazing start. We've written one whole word. Well, technically 3, but technically they're all without spaces, so technically not, but I don't know. Anyway, then we have equals global underscore position dot lerp. Then we're gonna get the starting position. Then we're going to get the speed and then the delta, and that should work. I think that will work. I think it'll actually work. It'll even go at the same speed as well. Okay, there's an error. There's an error. Invalid access to property or key global position on a base object of type nil. Well, that means your code is trying to read the global position of an object that does not exist. So I need to make it on ready. That's such a simple fix. Alright. We've done in record time. Now there should be no error. I am confident of it. Okay. You want to know what the problem with this is? It just teleports back. It just teleports back. Just teleports back. It just teleports back. I have a problem with that. It doesn't move how a crusher should move. We need to add some downtime between when it drops and when it goes back up and all that stuff. So we need to get a timer instanced, and we're going to do that in code. How to make the code wait a set amount of seconds. I know it's a timer. I just want to make sure it's correct. Oh wait, there's a forum here which is asking the same question. Well, that's really helpful. This person has even said the exact thing we need. So, oh, this person defines their own utility function to do this. But I think we will just be fine with this. Anyway, now once the floor rate collides, we need to, once it collides with the floor, we need it to, we should probably put this first. Then it will wait. And then we make the timer wait afterwards. And that should work, I think. Yes, it does work. It does work. Okay, that's good. That is good. That is very good. Of course, the player is not actually dying to it, but that's a problem for later. Okay, now what we need to do next is we need to add the pillar into it. And that's going to be hard. Okay, I should probably start with making a variable on ready the pillar. I'll make it with not a capital letter at the start. Then I'll put pillar. So pillar equals pillar. That's a variable. Oh yeah, we've done this comment. We don't really need the comments anymore for this script. We're just kind of doing our own thing. Also, isn't it kind of impressive that we've done this in 18 lines of code only? Anyway. So now we have the pillar. But that's the easy part. So we have the pillar sprite. Which should be somewhere here. Wait, let me find it. Yep, there it is. There's a pillar sprite. I'm just going to change its scale until it's the same as... Okay, it's a bit too big. Yeah, I think it can go in the middle like that. So basically, we need to register its top. Then we need to drag it down somehow until it reaches where the head position is. So how would we do that? Perhaps changing its scale.y would be sufficient. Maybe. So we need to get the top as a variable. So let's just go with the pillar top equals we're gonna need to look this one up. Go to how to get the top of a sprite 2D texture. This is a forum. I don't think this one is useful, though. It's about intersecting. Let's start simple. Let's rename this to pillar height since, well, pillar top doesn't really make a lot of sense. We want to get the height of the pillar, not the top. What if... Let's just start with typing pillar. Pillar dot. We can see some cool stuff here. So we're looking at the texture, right? So what if we... Texture. Oh, we can put texture. Then what can we put after texture? Can we put another dot? Expected identify after dot. Okay, that tells us we can put stuff after the dot. Okay, what if we put height? Does that work? It shouldn't work. It actually works. Wait. Print pillar height. Okay, now the game should print pillar height when we start it up. Okay, it's saying that this is nil, so it doesn't work. Let's just try the different stuff with this height. What if we put get height? Would that work? I don't know, let's just try it. Why is there a D and W in it? Okay. Yep, it doesn't work. Oh well, this line is invalid. Equals null. Okay. I'm completely stuck. Go dot how to stretch a sprite 2D texture between 2 points. You must calculate the distance between the points to set the sprite's length, find the angle between them to rotate it, and reposition the sprite's global position to the starting point. Okay, well, that sounds very enthusiastic. Anyway, we're just going to find centered, untick it. Then we're going to... Is this actually what we want to do? Set the Y offset to exactly negative half of your image pixel height. This is a negative half. Okay, well, minus 3.5, I guess. Wait a moment, is that the right thing? Oh no, we need to go to offset. Oh, okay. But negative half of 0 is 0. I don't really think this is what I need. Maybe this forum post will help. I want a simple effect for my 2D game where the character lands in something sticky and the jump height is drastically reduced. All I want is to take the following sprite and fix the bottom 2 vertexes to the ground and the top 2 vertexes to the bottom of the player sprite. So that as they jump, the image stretches for them. Okay, this is what we need. Okay. Wow, that pixel art is so much better than mine. Anyway. Sprites are just an easy-to-use textured rectangle, so there's no function to skew it freely, except maybe using shaders. I'd suggest using a custom drawn polygon by creating a node 2D. By creating a node 2D. Okay. Yeah. Okay, let's copy this. Let's paste this. Create a node 2D in your scene. Attach a new script to the node. Yeah, no, I'm not doing that. Okay, let's think about this mathematically. Let's just put this as a float. We don't know what value we need it to have right now. Let's just put it as a float. Actually, let's bring back the pillar top. And we're going to make it a float. I don't know which one of these two variables we're using, but they both seem useful. Anyway, from here on now, I don't really know what to do. Okay, what should stay fixed? The top of the pillar. That's the pillar top. What should move? The bottom should follow the crusher head. What must change? The pillar's height, which is this. So this changes, this doesn't. Okay, the pillar center. The pillar will have a center between the 2 points halfway between the fixed top and the crusher head. So the height equals the bottom minus the top. For example, if it was 0.20 and we had 0.10 for the top, we'd minus it and no, that maths doesn't make any sense. No, it doesn't make any sense. If it was... Wouldn't that just always equal the top way? Okay, anyway. You know what I've just realized? This should have head in front of it, so it's just the head that is lerping. Maybe all my problems will be solved by doing this. No, that did not help. That did not help at all. Alright, we'll remove this. So maybe we put the pillar inside. No, we add a child node. We call it a static body 2D. We put the pillar inside of it. We change this to equal pillar. Then we give it a collision shape. Okay, we are going to the backup plan. I'm going to be direct here. Go to how to get the pillar. Why am I searching up pillar? Go to how to get the texture of a sprite 2D. Yeah, I know you use the texture. And how to stretch it between two variables. I'm being very, very, very direct here. Oh, so you use dot get size. Oh, okay. Okay. Wait, if we remove those speech marks. Then we get the pillar height, which is 0, 0. I don't know what I'm doing. I feel kind of depressed. Okay, we need to think outside the box here. What if we made it so the pillar was visible pillar dot visible equal, we put it between these two timers, pillar dot visible equals false, and then here we have pillar dot visible equals true. Okay, now we're getting somewhere. We need to put the pillar at the top of here so it renders behind the crusher. Yes. Now we can render it so that in zone 1, level 1, oh yeah, we should probably make the pillar larger first. Let's just make this 5.0 again. Kind of needs to be 5.0 if we're really doing this method. Anyway, we go to zone 1, level 1. We go to the crusher. We go to the pillar. We drag the pillar over here. Yeah, the pillar needs to be way larger. Let's see. Its Y has got to be stretched out to 10. No, I need to unlink this. Its X can still be 3. And then essentially, we make its Y smaller. And then essentially, the overlap between the crusher falling down and the, you see, it's a good compromise. Wait a moment. We edited its scale just then. We edited its scale just then. Okay, here's a suggestion. What if we increase its scale? Go to how to change scale.y of an object in code. Okay, so we just use .scale.y. I answered my own question there. Okay. Pillar.visible equals true. Okay. Then we have export the pillar max height. Then we have a packed string array. Wait, no, I need we can just use this. Save the scene. For some reason, it still thinks it's a packed string array. Go dot how to export a variable so you can set the number. Oh wait. Oh yeah. I'm really weird because I forgot the most basic function of exporting. Okay. max scale, I should say. Scale. Then we can set it to 10, for example, here. Then, so we're just going to check that this works right now. So we can see that the pillar does indeed go down to the bottom with the crusher head. Then what if we divide the pillar max scale by 4, the pillar scale increase and equals pillar max scale divided by 4. Why doesn't that work? Oh, because it's not using the block. Yep, we'll just put this in. Then we just lerp its scale. Go on how to lerp scale of an object. So I can just use scale equals scale.lerp target scale speed. Oh, okay, so our pillar max scale is our target scale, essentially. And then we have the scale speed. So instead of the increase, we have the scale speed, which we'll put at 2. Anyway, then we have the scale. Okay, so we have the pillar dot scale equals scale dot lerp target scale. No, it's actually the pillar max scale. Then we have the scale speed times delta. Argument 1 should be vector 2, but it's int. Oh, it needs to be a vector 2. Vector 2. Oh, okay, there we go. Then we set this to 10. Then we set the pillar dot scale equal. No, this should work. I think this should work. I think we've finally found a solution to our problems. No, it does not work. Why isn't it working? Oh, wait. Do I need pillar dot scale dot lerp here? Last time I put something in front of something, it didn't work. Okay, that does not work at all. That does not work at all. That does not work at all. Wait, what if we made it still visible? Wait a moment. We need the X to be 3, right? No, it's 5. Yeah, this is essentially a weight simulator at this point. I don't know what I'm doing. I'm going to give up. In fact, the only thing I can do is set its scale to 1 and 1 here. Place it at the top of the crusher and hope for the best. I mean, that's all I can do. And it doesn't work. It doesn't work. The pillar flies up for no reason. It flies up for no reason. It flies up for no reason. It flies up for no reason.